Welcome to eFilms on location at Meetung. This is a perfect example of what an owner-builder should aim for. This house has many features in sustainability as well as a 5-star or higher rating.
Designing the house took me about a month. Researching the products and the stuff that I put into the house took me about 4 years, 5 years.
Are you happy with the result?
Ecstatic.
What Energy Star rating is the house rated at?
Would you believe 4 stars?
Why only 4 stars?
Because at that stage, when they had the software rating houses, it couldn't handle houses built on stumps, nor could it handle rammed earth, mud brick, or anything else that was highly sustainable building design. It was only designed for a brick veneer on a slab. And so if we ran it through the star rating now, we'd probably get close to 6.5 stars.
Approximate cost to build the house?
Around the 360,000.
And what year was that built?
It was built 6 years ago, which was 2004.
Now, did you build this house yourself?
No, we contracted a builder in to do it. Furphy Enterprises, Graeme Furphy, and a great guy. If you're going to build a sustainable house like this and research your products, make sure you're working with a builder who's happy to work with those products as well, because a lot of builders won't. This guy, to his credit, he was totally flummoxed when we told him about all the different things we were going to put into this house. But to his credit, he researched everything himself and he made it all work. A star-rated home, all it does is look at the thermal building envelope. It looks at the orientation of the windows, it looks at the orientation on the block, the size of the windows, and things like that. Mainly the building envelope itself. The difference between that and a sustainable house is what goes into the house. The lighting, the type of curtains that you use, the type of flooring that you've got, the type of decking that we've got there, for example, the type of heating we've got. All of those go into making a sustainable house. It's something you're going to live in, and sustainability is more the behaviour that you're going to have within the house and how you're going to use that house rather than the building itself.
Does it cost more to put these sustainable features into a house when designing?
No, not really. The pellet fire that we've got in there that you'll see later costs no more than a normal wood fire. The decking is recycled plastic and timber boards. It's about twice as much as Merbau, but it lasts for 25 years, where Merbau only lasts for 10 years. We've got timber window frames. Okay, they're a little bit more expensive than aluminium, but in the long run, in terms of heating and cooling costs and the way this house works, it's actually going to be cheaper in the long run for me to have this house than a normal house.
On this house, are you connected to mains power?
Yes.
Are you connected to sewerage?
No.
Water?
Yes.
Tell me a bit about the water storage on this property.
Okay. Even though we're connected to mains, we decided that we'd want to work from tanks and be self-sufficient on water. So what we've got is we've got 2 5,000 gallon tanks, or 45 odd thousand litres of water. The tanks are full. That is connected to a pump that pumps through the house, and on the pump is a sensor device. If the level in the tanks goes down to a certain level, the system will automatically switch over to mains. And behind the tank we have the rain bank system, which is that system that, let me show you. And this device on top actually measures the level of water in the tanks, and if it drops below a certain level, it automatically switches over to mains for us. Apart from that, it's a normal standard pumped house.
How long did it take to fill the tanks up?
1 weekend. We had 273 millimetres in 1 month down here, just after the house was built. And so it took, just about a weekend to fill the tanks.
How many litres?
45,000. So we've got 234 square metres of roof area. Every millimetre of water that drops onto the roof, we get 1 litre into the tanks. 230 litres in the tanks for every millimetre that drops on the roof. Instead of having a septic tank, because we don't have main sewage here, we've got a worm farm. So we have a big tank in the ground with straw and peat and gravel and sand inside, and basically all the grey water and black water goes in, lands on the pile of straw at the top. The solids stay at the top where the worms live, and the worms eat all that. The liquids get filtered through the straw and the peat and the sand and the gravel, and then gets pumped out to a 200 square metre area under my orchard, about 300 mils under my orchard, so it actually waters the trees from underneath. And there's a Dalek at the top. It's just basically a compost bin, and we just feed all our food scraps and things from the kitchen down there to feed the worms as well. So we get some nice healthy vermicast that goes and feeds my trees. What we've got here is we've got a dry riverbed that goes all the way down to the dam, and the overflows from the tanks actually appears as a pipe down, and the overflow from the tanks is captured by the dry riverbed and sent straight down to the dam. And that way we don't lose any water, and we use that dam for firefighting. A lot of people will tell you that if you've got mains water, you cannot run your house off tanks. That I found out was a fallacy, especially in the state of Victoria. The main concern you have is particulates in the water and things like cryptosporidium and other nasties. If you've got some decent water filters like these on here for drinking water, then you overcome that problem. And I change those filters every year. This house is highly insulated. We've got R3.5 insulated bats, polyester bats under the floor. We've got R2.5 and wrap in the walls, and we've got R3.5 and wrap in the roof. And the beauty of being able to insulate underneath the house, and this is the beauty of having the house built on stumps, is that you can retain that heat. Hence, it reduces our heating costs. This is the roof space, and as you can see, we've got a fair amount of insulation up here. This is that R3.5 I was telling you about. Plus, we have the wrap on the roof here, which helps reflect the heat back out again. The pitch of the roof, as you can see, is a lot steeper than a normal house. It's a 34-degree pitch, which for this latitude actually maximises our solar capabilities in winter, which is the time you want it the most.
So 34 degrees is the panel angle?
Yes.
The most suitable?
Yes. Yeah. It normally relates to around about the latitude, your current latitude.
And the rating on that insulation is?
1.5,
1.5, isn't it?
Yeah, something like that.